Hi guys, I hope you are fine. Me too, I'm fine. Mine is to wish you a happy new year and a prosperous 2025. Guys, I'm back with my videos, and today guys we are going to look at integration. And so I read this question and then we continue. Given that 4x squared plus 4x plus 2 is equals to u squared plus q, where q is a real constant, determine u and q, hence find the integral. So guys, we come and now write the question. We can write this one like let 4x squared plus 4x plus 2. This one is equals to u squared plus q, like that. Guys, we can also say that let u, which is this u, be equal to, because now guys, this we know is a quadratic equation which normally have two factors, and those two factors are written like ax plus b, and then you multiply once again with ax plus b if it is squared. So what we can do here guys is that for the very first factor here, we know it's supposed to be, when you square it you get 4x squared. So this one is now going to be 2x. That one guys, we are aware of that. But the second one, we may not find it easily, so we'll have to find what it is. So let me guys give this one n like that. Let it be unknown. As of now it's unknown. And then when we come to square that, I'm not squaring right now, plus q is when now we get that. So guys, we can now go ahead and now perform this operation. And so therefore, we will have now u squared, which is 2x plus n. You square that. Maybe I can square it here. 2x plus n, like that. Now plus q. So let's find out what we get from there. So now we have 2x multiplied by 2x, you get 4x squared. Then multiply that by that, you get 2xn plus 2xn plus again 2xn, finally plus n squared, and then plus q. Guys, this one is equated to, I write the equation there, 4x squared plus 4x plus 2. So guys, now we come and compare both the equation, whereby if you look at this guys, this one looks the same as that. Then we have the coefficient of x. For the coefficient of x, here we have 4. And so we can say on this other side, we can add this, whereby we say, maybe I can go still another step guys, before even I come to what I want to say. I now come and simplify this. So if I simplify, I'll get 4x squared plus 4xn. Remember that these are the same, so you just add the constants and then the rest you write the same the way they were. Then plus n squared plus q. This is what now, guys, we want to equate with 4x squared plus 4x plus 2, like that. We are equating those. So as I have said there earlier, this 4x is similar to that 4x squared. 4x squared is similar to 4x squared. When we come now to coefficient of x, this side is 4. The coefficient of x this side is 4n. So we can say 4n is now equal to coefficient of x this side 4, like that. Because this is a constant, this is a constant. So the coefficient of x is 4n. Coming to this other side, we have this other coefficient, because this one is now does not have x and this one does not have x. So we say the constant on this side will be the same as constant on this side. The constant on this side is n squared plus q is now the same as the constant on this other side too, like that. So guys, for the n, this one we get n is equals to 1 according to this equation. You divide by 4 this side, divide by 4 this side. After getting n is equals to 1, come and replace your n here. So you have 1 squared plus q is equals to now 2. Therefore, guys, our q then should also be equal to 1. Because here we have 1 plus q is equals to 2. So q is equals to 1. And so guys, we are now able to find, therefore, u is equals to, we had said 2x plus n here, as you can see here, 2x plus n, and our n is equals to 1. So u is equals to 2x plus 1. And then q is equals to 1. So guys, that's what we were looking for. So guys, we've been able now to find our u according to the equation. Determine u and q, and that's what we have found out. So guys, that is our u and that is our q. So we can give ourselves a right there and a right there. So guys, let's now go to the next question. So guys, we are now supposed to solve this question because the question states, hence find the integral. This one. Whenever you find the word hence, it means you have to use whatever question, the solution of the first question, which was now u is equals to 2x plus 1, q is equals to 1. And so guys, we transform this question in this way. This is now going to be integral. This is integral x dx all over instead of writing 4x squared plus 4x plus 2, we write it in terms of u and q. And this is going to be 2x plus 1. This one is now supposed to be squared. And then plus q, which is now 1. Guys, we can try and do this and see whether you get this. And so from there, guys, we now come and now perform the integration. And this is how we do it. We say let 2x plus 1 be equal to tan u. Whereby now, this one can also be, you can also say that tan inverse 2x plus 1, this one now also gives you u, like that. And then from there, guys, we can now differentiate both sides. If we differentiate this side, you get sec squared u. While this one you get differentiate with respect to x. This one you get, sorry, with respect to u. This one you are going to get 2 dx du, like that. This is a constant. You don't get, you get 0, or you don't get anything. So now, from there now, you can now, because we want to substitute for x there, this is dx, we can now say this dx is equals to sec squared u is all over 2, like that, and then du will come here now. This is now du, like that. From there, guys, we come and now substitute our figures here. This we substitute this. So this one is now going to be equal to integral. We substitute the x for this one. For the x for this one, guys, we can actually do it maybe somewhere here, where we say 2x is equals to, for this one, tan u minus 1. Then x is now going to be equals to 1 over 2 tan u minus 1, like that. So this one is our x. So I can write, instead of writing x, I can write that. So this one is going to be, I can write, I have here. I'm now replacing for x. This one is going to be tan u minus 1. And then I can now come and replace for the dx. For the dx, we have sec squared u all over 2, which 2 I can also add here. That is multiplied by 2 once again. And then from there, I am left with this. Here we have the du. And here we shall have now our u here. Because we said not u, but tan u. So this one is going to be tan squared u plus 1. Like that. So that's what we are having, guys. So let's continue from there. This one now is going to be 1 over 4. Like that. And then, guys, here we are going to have tan u minus 1. This sec can also be written like we usually have from trigonometry. We have 1 plus tan squared u equals to sec squared u. And so guys, we can replace that with sec with 1 plus tan squared u. So instead of now writing sec squared u, we write 1 plus tan squared u. And then here we have the du. And then we can now draw the line there, all over tan squared u plus 1. Guys, now you can see that this can cancel. That can cancel that. And so we are left with the other figures. So guys, this is now what we have. Now we can write the remaining figures, expressions, which is now 1 over 4 here, integral tan u minus 1 du. So this is what now guys we are going to integrate. And this one we can now remembering 1 plus tan squared u is equals to sec squared u. We do this question with that in mind. And so guys, we are going to have a quarter integral of tan u, that is doing them separately, that is du, plus again we have, that is minus a quarter, because now guys what we are doing, we are multiplying this quarter with that and this quarter with that, then we integrate them separately. So we shall have here a quarter integral of 1 du, like that. So guys, with that one we will have here, before we continue, we had said that let 2x plus 1 be equal to tan u, like that. And we also know that 1, that is according to this one, that is 1 plus tan, that is tan squared u is equals to sec squared u. So therefore guys, as we do that, we have that in mind. So this is now going to be equal to the integration of 1/4 integral of tan u is going to give us 1/4. The integration of tan u is usually supposed to be, according to the tables, if you look at the mathematical tables, you get ln sec u, like that, minus the integration of 1, you get 1 all over 4 u, like that guys. Then plus, we don't forget the constant. So guys, we can now convert this one in terms of x. So we shall have 1/4 ln sec u. For sec u, we find the square root of that side and the square root of that side, because the square root of this side gives us sec u. So we are going to have here 1 plus tan squared u, like that, and this one now is going to be square root, like that. This is now the square root That is for the sec u, still in terms of u. And this one is gotten from this equation. Because if you divide the square root this side, square root of this side, this is going to be sec u, which we have here. And so this square root of that one is going to be, we're going to replace it here, sec u for sec u. Minus, now, when we can put it like that, minus a quarter for u here, we shall have from this, you can have tan inverse 2x plus 1. This one gives us u. And so therefore, guys, this is now going to be, instead of u, we'll have tan inverse 2x plus 1, like that. Then plus c. So finally, guys, this is now going to be our solution. A quarter ln square root 1 plus tan squared u, which is now tan squared, and then our u is supposed to be, so guys, this tan squared u, as we can see here, maybe to show you here, you can see that let 2x plus 1 equals to tan u. So this one is what we are going to replace. So before I write that one, this expression, guys, I can say that this one is equals now to be 1 quarter ln square root 1 plus, and now replace it with 2x plus 1 here, 2x plus 1 squared. So that's how it is going, this is going to be. And so finally, guys, our solution then will be equal to, I'll write this one first. I'll write 1 all over 4 ln, that's ln square root 1 plus 2x plus 1 squared, now minus 1 all over 4 tan inverse 2x plus 1 plus constant. So guys, this is then our solution for that. And so guys, thank you for listening to me. Bye bye.